Thermal paste pads. While a massive heatsink and high-speed fans are essential, they are useless without thermal interface material, TIM. Even the most polished metal surfaces of a processor and a heatsink look like a range of jagged mountain peaks and deep valleys under a microscope. If you press them together, dry, air, which is a terrible conductor of heat, gets trapped in those valleys, creating a barrier that causes the processor to overheat in seconds. Thermal paste and pads are designed to displace that air and create a solid heat bridge. Thermal paste, the liquid bridge. Thermal paste, also called thermal grease or compound, is a thick, conductive fluid. It is the most common TIM used for CPUs and GPUs because it is highly effective at filling those microscopic imperfections. Composition. Most high-quality pastes use silver, aluminum, or ceramic particles suspended in silicone. High-end, liquid metal pastes use gallium, which is incredibly conductive but can be dangerous because it is electrically conductive and can corrode aluminum heatsinks. Application methods. The goal is to apply just enough to cover the surface without it oozing out onto the motherboard. The P method, a single small drop in the center. The pressure of the heatsink spreads it evenly. The X method, two thin lines crossing to ensure better coverage for larger processors. The spread, using a small spatula to create a paper-thin layer before mounting. Thermal pads, the gap fillers. Thermal pads are preformed, squishy pieces of conductive material. While they aren't quite as efficient as paste for high heat transfers, they are essential for other components. Primary use. You will find these on voltage regulator modules, VRMs, video memory chips, VRAM on graphics cards, and M2 SSDs. Gap bridging. Unlike a CPU, where the heatsink is perfectly flat against the chip, VRMs and memory chips often have slight height differences. A thermal pad is thick enough to squish and fill those uneven gaps between the chips and the large metal cooling plate. Ease of use. They are much cleaner than paste and stay exactly where you put them, making them ideal for manufacturing and quick repairs. The technician's maintenance rule. Thermal interface materials do not last forever. Over time, the silicone in thermal paste can dry out and pump out from between the surfaces due to repeated heating and cooling cycles. If a computer that used to run cool is now hitting high temperatures or throttling, a technician's first move, after checking for dust, is to repaste. This involves cleaning the old, crusty paste off with 90% or higher isopropyl alcohol and applying a fresh, high-quality compound. Phase change materials, the modern middle ground. The newest advancement in cooling, often seen in high-end laptops, is phase change material, PCM. These act like a solid pad when the computer is off, making them easy to install, but they turn into a highly conductive liquid the moment the processor hits a specific temperature. They offer the ease of a pad with the performance of a paste and are much more resistant to drying out over several years of use.